Flood versus drought. So you are aware about the flood and the drought. Both can happen anywhere. But today we'll understand both can happen in the same year. Suppose you have a huge amount of rainfall, you will see the flooding. And the same year, if you have a dry spell, like more number of dry days, you will face the drought. Okay. So the today's topic is same area, same year, and you are facing flooding and the drought. So we need to understand why it is happening. Okay. So to understand this, we have to understand the hydroclimatic variability because it is continuously increasing, manifest as intra-annual extreme, where the same region experience both flooding and the drought within a single year. Okay, so this presentation will cover the atmospheric drivers. So in atmospheric drivers, we will talk about the how the clouds will move from one place to another place. That is number one. Second number, like how the wind direction will support to the cloud and how it is moving from one place to another place, and then the precipitation will occur. Second, we will also discuss about the land surface feedbacks. Okay, suppose the precipitation occur, so the entire water will go as a part of the runoff, or there will be some chances for the infiltration that it will recharge to the groundwater. Okay, so we'll talk about the feedback system of the land surface, and the third one is like hydrological process that produce such contrast. Okay, so in hydrological process, that is just like a repetitive cycle. So that will be the hydrological cycle. So I will cover in next class. But here we'll talk how it will be interlinked. Okay. Then we will go to the detailed assessment about the flood and the drought, and then we'll cover some kind of examples. Okay. So another things, it provide a diagnostic framework and present multiple case example relevant to the monsoon in arid and the semi-arid region. So this drought condition and the flood condition can happen anywhere. Let's talk about the governing mechanism. So there are multiple governing mechanisms, but we will cover only few. That is contributing measure in terms of the flood and drought. So first is the rainfall distribution. So we need to understand the seasonal and the temporal variability of the rainfall. That is why this is the key component, and we took as a first. Okay. So the total seasonal rainfall may be normal, but distribution is skewed. Like suppose if you're located in one place like in Badwani, okay, and the second place you're located in Bhopal, that is in Madhya Pradesh, India, okay. So Badwani and this Bhopal rainfall variability is there. Both places having the different kind of rainfall amounts. So some place are having the higher amount, some place will be the lower amount, okay. So some place will face as a drought condition if there is very less amount of rainfall, and if the second place will receive the more amount of rainfall, so it will be the flooded. Okay. So some example like 60 to 80% rainfall in 5 to 10 events, that is extreme events in a year. So if there approximately 60 to 80% rainfall will precipitate within 5 to 10 days, then you just think how much rain amount is coming. So you can see the flooding in an entire region. Okay, so this is the major factor where we can observe the flooding. The second is extended dry gaps, like the gap between the two rainy event. Okay, this is huge. So it will trigger the drought. So that will be the agricultural drought and it will be the hydrological drought. Okay. The next one is climate drivers. So we need to think how we can correlate this large scale climate drivers. For example, El Nino. So El Nino is a it will alter monsoon strength and spatial rainfall distribution. Okay, so El Nino year suppress rainfall overall, but localized extreme event still occurs. And IOD, that is Indian Ocean Dipole. So if it is positive, so it will enhance rainfall over parts of the region, like India and East Africa. And I will give one example regarding the regarding the Africa based on the IoT. Okay, and if you can see the IoT, so it will also can cause the episodic flooding. Okay, and the next one is synoptic and mesoscale pattern. It is like a monsoon depression and a low pressure system produce higher intensity of the rainfall. So if a stationary system is there, then localized flooding you can observe. If absence of system, then prolonged dry spell will be there. Okay. And the next one is land surface feedbacks. So in land surface feedback, there are two options. First one is like soil moisture dynamics, and the second one is land use and land cover change. So let's talk about the soil moisture. So rapid runoff during the intense storm. If there is a huge amount of rainfall, so you can see the continuous runoff, and there will be very less chance for the infiltration. Okay, so there is the main reason it will be limited. Your infiltration factor will be limited, and you will see the very less amount of recharge into the subsurface. Then soil moisture decline quickly after the event, so it will trigger to the drought condition. So this soil moisture can give the information about the flood, and also it will provide the drought information. The second one, if we talk about the land use and land cover, so urbanization. So urbanization, that means there is continuous built-up area is increasing. So just for example, today the entire area is forest or maybe the green cover area, where we can observe like some trees, some agriculture farmhouse, some farmland, some water bodies are there. So if the rainfall trigger, then there will be chances for the infiltration. So water will go and it will recharge to the subsurface. Okay, but suppose if the entire area is cemented, like the urban jungle, so the buildings are there. So if the rainfall will be there, so the entire water will flow as a part of the runoff. So if urbanization is there, so there will be chances for the increase in impervious surface, and if impervious surface is there, then you will face the flooding. The second is deforestation, so it will reduce the infiltration, and again you will see the flooding. The next point is like cryospheric and temperature effect. So here, if you just see about the Gangetic river system or the Himalayan river system, so some rivers are the glacier fed, like snow and ice melt is there. So that will contribute during the summer season, and during the monsoon season, rainfall will contribute. So this is also the another factors. The next factor is hydrological storage limitations like low groundwater recharge. So if low groundwater recharge, if there is a high flood or maybe the high rainfall, so entire water will be flow as a part of the runoff, and you will see the very less groundwater recharge. So short duration, high intensity rainfall. So here, if you have a rainfall, duration is very short, but the intensity is high. So it is a major factor where you can find the flooding. And the poor aquifer connectivity, like the aquifer system or maybe the lithology or the soil type, subsurface lithology, it indicate like a very less connectivity. Okay, so infiltration factor will be very less. So it will trigger to the flooding during the rain events and water scarcity post event. Okay, then the next one is like some diagnostic indicators. So we'll talk about four components or four indicators. So first indicator is the rainfall intensity. Second indicator is the moisture, soil moisture. Third one is the stream flow, and the fourth one is the groundwater. So these four indicators we will cover. So first, suppose if you are thinking about the flooding, so flood phase, you have a huge amount of rainfall, saturated soil will be there, and peak discharge. Peak discharge like the highest amount of runoff. Suppose there is a small stream, and in a stream, huge amount of water is going. So sometime you will face the flooding, like water is going left bank or even the right bank of the river. So there is a peak discharge or the total flow in a particular river or the maximum flow in a particular river or a stream. Then limited recharge. So recharge, that means in terms of the groundwater point of view. And if you face the drought condition, so the rainfall amount will be very less. You can see the rapid depletion of the soil moisture, base flow decline. Base flow, that means if we talk about the river, so in the river during the uh, monsoon season, you can see the continuous water that is approximately above the surface. Above the surface in the channel, we can clearly see. But in a central, like in a thalweg or the lowest portion of the river bed, we can see some kind of moisture content where you can observe the base flow. So the base flow is also declining if the drought condition is there. And the next one is like water table falling, like groundwater level is declining because people will use the groundwater level or groundwater data or the water level for their domestic and irrigation purpose. Okay, so if drought condition is there, you can see the tube wells, so people will abstract the water from the tube wells and they will use for their domestic purpose. So the next one is like East Africa. So East Africa, there was flooding, like intense rainfall linked to the positive IOD and drought condition consecutive failed rainy season in the adjacent period. Okay, so they faces the crop failure because of the floodings. The next case study for the Rajasthan. So Rajasthan, we have seen the localized cloudburst, and in a recent year we have seen the flooding. Okay, because Rajasthan is receiving very less amount of rainfall. That is our historical record, but in a last year or last year, it is faces the flooding because the channel pattern or the water flow pattern is not designed as per the recent rainfall. Okay, and throughout the year they are facing the water scarcity problem. Okay, and this indicate low infiltration plus high evaporator transpiration. Okay, and the right is the that was published in Down to Earth magazine. So you can just see the source and you will find the detail about the Rajasthan flooding. So next one is like integrated explanation. How we can integrate all the explanation. Okay. So in a like if we just see the final remark, so flood and drought co-occurrence is not contradictory. Okay. So it is not contradicting to each other. You can say it will be happen on the same year. Okay. So it will reflect temporal mismatch in the rainfall concentration. Okay, and its distribution. The second, we have heard about the spatial heterogeneity, like basin scale variability, that is the different water set, and the storage failure, like surface water and the subsurface system unable to retain the water. And the last one is the climate variability application. Okay, so climate, why we have used this word, because of the climate change, we can see the variability into the rainfall pattern. Okay, so in conclusion, we can say the co-occurrence of flood and drought within a single year is a direct outcome of the hydroclimatic variability, combined with inadequate storage and altered land surface process. The second, we can say effective management require transitioning from rainfall-based planning to storage and distribution-based water resource strategy, supported by high-resolution data and integrated modeling framework. Okay, so we need to understand this phenomena, why we have observed the flooding and the drought in the same year. So we need a detailed study, and in detailed study, we can just use the historical data, we can use the climate projection data, we can use the other published data set, so that we are in a position to provide which area will suffer more flooding or the drought condition in the coming future. So now you understood about the flooding and the drought condition in the same year, and I hope this video is interesting. Yeah, thank you.